All right, this lesson is about sinusoidal functions. It's a very nerdy word. And we're just going to take a look at the function portion of sinusoidal function, not so much the graphing. That will be for next week because it's a little bit challenging. And before we can actually graph anything, we have to know how these sinusoidal functions transform, how they get smaller, how they get bigger, how they shrink, how they move up and down and side to side. So if you look here, it says y equals a sine of b times t minus h plus k. And the variables that are in color are the ones that we talk about the most, and you already learned about a couple of them. For instance, we already know what a is because of our previous lesson. A stands for the amplitude. And amplitude is very simply the distance from the midline to the highest or lowest point of your function. And then we learned about k, which was our vertical shift. This is what moved my graph up and down. All right, so what does b and h mean? And first of all, before we move forward, this t symbol, that represents the variable that the function is working with. So any x or m or z or t or whatever variable that you have. So b here is a little bit funky because b stands for the very fancy word of angular frequency. Now, we typically don't use this word. We usually just say that it's the period. So aka period. And so anytime a function repeats itself over and over again, that's called a periodic function. And so off to the side here, I'm going to draw the parent function for the sine graph, which looks like a sideways S, so S for sine. And if I were to continue this graph out here, this would just keep going on and on and on and on. So it's kind of like it repeats itself. So that's what I mean by a period. And there's a specific way of how to determine it. And this is the formula that they use. It's 2 pi, and we use 2 pi because that's the radian measure of a full circle, of a full revolution, okay, over the absolute value of b. So b is going to be some kind of number, okay? And we'll take a look at an example so that you know what that means. Just understand that that's what it is for now. Now, h is also a shift. It's not vertical this time. It is the horizontal shift. And if you remember from quadratic functions, if this h is inside the parentheses, then it has the opposite sign of the sign in front of it. For example, if that said t minus 2, that means that my graph has been shifted to the right by 2 units. So right 2 units. And if it was t plus 2, that means I go to the left. All right, now, one other thing. K also stands for the midline, which we learned about before. And you will see how these two concepts in orange mimic each other when we start graphing them. But for now, just understand that it's the midline, which is the same exact thing as the vertical shift. So let's take a look at a problem to see what all of it. Okay, so here's our first example. So this says y equals the sine of pi over 2 times t. So we are going to, one by one, determine all of our variables. Okay, and this is another reason why I really like color coding. So first of all, a is going to be the coefficient of my trig function, and remember that sine could also be cosine. The rules apply the same exact way for both of them. So I see in front of this sine here an invisible number 1, and it is understood to be there. So in that case, it makes my amplitude 1. Now let's go and do k again, since we know how to do that already. So k should be our midline, and that means that it is whatever is being added out to the side here, which there isn't anything there, so that is automatically 0. And because this is a line down here where it says k, I need to write y equals, and then I'm going to write 0. Now, within the parentheses, let's take a look at our horizontal shift. That's the next easiest one to look at because I don't see a subtraction sign or a minus sign within those parentheses, so anywhere in here. And that just means that there is no horizontal shift. So down here where it says h, I'm just going to write 0, because that would be like me adding or subtracting 0. So b here is the main thing that I am concerned about. And if you remember before, in order to determine what b is, or what the period is, this is what I need to do. And that's what I'm concerned about. So when I look for b, I want to know what is the period. How long does it take me to make one complete revolution? So I'm going to go ahead and write this out. Now up here, this right now is b. The coefficient of t, that is b. So that's what I'm going to substitute into the equation here, or into the formula. So 2 pi over the absolute value of pi over 2. Now, since this is already positive, we can cancel out the absolute value bars. So 2 pi over 2. Now, this is actually division of fractions. So I could rewrite this as 2 pi divided by pi over 2. That's exactly what that's saying. And I know that 2 pi is the same thing as 2 pi over 1. And if you remember your algebra rules, in order to divide fractions, we multiply by their reciprocal. So 2 pi over 1 times 2 over pi. And what's interesting here is that the pi's will cancel each other out. And does that happen every single time? No, it does not. So 2 times 2 in the numerator is going to give me 4. 1 times 1 in the denominator gives me 1, which is very simply 4. So that is the period that I am dealing with. So a little bit more specifically with that angular frequency, this number here, the number that you get after you do this 2 pi over absolute value of b, this is the period. B itself is that angular frequency. Okay. All right, so let's take a look at a problem that might be a little bit more challenging. All right, so here we go. Y equals 2 cosine 3t minus 6. So very quickly, I can determine the two easiest parts of this, which are the amplitude and the midline. So let's go ahead and do that. So the coefficient of my trig function is 2, so that is my amplitude. And whatever is being added out here to the end, which in this case is 0, is my midline, so y equals 0. All right, two easiest parts done. Now what are b and h? Well, here's the thing. Up here at the very top, this piece right here, when you look at this, this does not look exactly like this. And that's a big problem. In order to use these rules, your equation, your function has to look identical to the formula that has the rules with it. So this almost looks like it's been factored. So the b was a common factor of something that involved t and h. So let's take a look at this 3t minus 6 business and see if we can't write this so that we can factor something out to look more like our original function. So 3t and 6 both have a 3 in common. And that's all that they have in common. So I'm going to write that out here, and I'm going to pretend that that is my b for now, since that's exactly where it would lie in that original function. So 3 times what gives me 3t? Well, that would just be t. and then minus, and then 3 times what gives me 6? Well, that would be 2. So parenthesis, parenthesis, and then out to the end, I still have plus 0. And I'm going to change the 2 in red so that everything is color-coded appropriately. So come on, red. All right. There we go. So now when you look at this, this does look much more like our original function, and that's what you need to do. So the period and the horizontal shift, you really need to be careful for and watch out for this, because if there is something that you need to factor, you have to do that. So now my horizontal shift is this 2 here, and since there's a minus sign in front of it, that means I move to the right 2 units. And you can use any kind of notation that you want to for this. It's okay. Just make sure it's easy to read and so that I could understand it without you having to explain it to me. All right. So here we go with B. Now, first of all, this number 3, remember that stands for the angular frequency. That is not my period, and that's what I want to know. What is the period? So that I have to do 2 pi over the absolute value of B. And B in this case looks like it is 3, so we don't need the absolute value bars because it's already positive. And when you look at this, there really is nothing else to simplify. This kind of looks like a radian measure, and that's okay. This is as simplified as it's going to get. It's a lot cleaner than a decimal, so that's my answer. So I know my amplitude is 2, my period is 2 pi over 3. This function has been shifted to the right 2 units, and my midline is at y equals 0. Now, let's take a look at one more with all 4 pieces in it. All right, so here is our next example and our last one for this tutorial. So y equals 3 sine 4 times t plus pi plus 5. Now, this type of example should really be a piece of cake and even easier than the last one. Because first of all, the hardest part of this, where we find b and h, this already looks identical to the formula above it. So there should be no manipulation here that I have to do, no factoring at all. Let's go ahead and do amplitude first, since it's always the easiest. Coefficient of the trig function, which is 3. And the next easiest part, which is the midline, which in this case would be plus 5. So that means my line is at y equals positive 5. And b, which happens to be this 4, which is the angular frequency, is going to go for b. So 2 pi over 4, and I'm not going to use the absolute value because 4 is already positive. And this is going to reduce to pi over 2, which is fantastic, so that's my period. And then the horizontal shift is going to be the pi symbol inside the parentheses, and it has a positive sign in front of it, which means this is going to be shifted to the left by pi units. And you don't have to write the word units. I'm just doing it so that you can see what I'm talking about. And that's all I do. So it gets easier and easier every time you do it. Just take your time.